Hello students and good afternoon. So now I am doing class 12 science. The topic is the same topic that we were doing in the last online class, that is integration of some special form of functions. So in that online class we did some problems. So today is the continuation class. Same exercise 8, page number 396, 4 mark section from the book Higher Mathematics for Class 12 by S.N. Day. So let us evaluate this integration, that is question number 30. That is integration of dx divided by 3 plus 2 sin x plus cos x. So we are doing this type of problems in the last online class. So I already told you that whenever you have a plus b cos x or a plus b sin x, you should write cos x or sin x in terms of submultiple angle, that is in terms of tan x by 2 from the submultiple angle chapter in trigonometry. So in this case also both sin x and cos x are there. Okay, so instead of sin x you have to write it in terms of tan x by 2, and you have to write cos x in terms of tan x by 2 from submultiple angle in trigonometry. So let us do this integration now. So I is equal to integration of this is dx divided by 3 plus 2 into within bracket, this is 2 tan x by 2 divided by 1 plus tan square x by 2 plus. So what is the formula for cos x? It is 1 minus tan square x by 2 divided by 1 plus tan square x by 2. So I think you have understood it. So let us take the LCM now. So or I is equal to integration of this is dx divided by, now in the denominator let us take the LCM, that is 1 plus tan square x by 2 is the LCM, and you know how to simplify it. So 1 plus tan square x by 2 should be multiplied by 3, so it is 3 ones are 3 plus 3 tan square x by 2 plus 2 2s are 4, it is tan x by 2 plus 1 minus tan square x by 2. Is it understood now? Just we are simplifying it after substituting the formula for sin x and cos x. Okay, so or now this is I is equal to integration of, now this 1 plus tan square x by 2, it goes up in the numerator, so it is 1 plus tan square x by 2 dx, this whole divided by, now 3 tan square x by 2 minus tan square x by 2, what is it? 3 tan square x by 2 minus tan square x by 2 is 2 tan square x by 2. This is 2 tan square x by 2, right? That is 3 tan square x by 2 minus tan square x by 2 is 2 tan square x by 2, then 4 tan x by 2, then it is 4 tan x by 2, right? 2 2s are 4 tan x by 2, and then next one is 3 1s are 3, and 3 plus 1 is your 4. That is 3 plus 1 is 4. Okay, so next, or I is equal to integration of, what is the formula for 1 plus tan square x by 2? It is sec square x by 2 dx divided by, denominator is kept as it is, 2 tan square x by 2 plus 4 tan x by 2, 4 tan x by 2 plus 4. Is that clear now? So now we can do the method of substitution, because you know that the differentiation of tan x by 2 is sec square x by 2 into half. That means we are getting the numerator. If you differentiate tan x by 2, we are getting sec square x by 2 into half. That is the numerator. So we can assume let z is equal to tan x by 2. Okay, so let us differentiate it. So differentiating both the sides, differentiating both the sides with respect to x. So therefore, this is dz by dx is equal to, what is the differentiation of tan x by 2? It is sec square x by 2 into half. So I hope you have understood it. So next, now we can do cross multiplication. So it is sec square x by 2 into dx. Cross multiply by 2 here, it is 2 dz. Is that clear now? So that means we are getting the value for sec square x by 2 dx, which is equal to dz. So therefore, I is equal to integration of, what is sec square x by 2 dx? It is 2 dz divided by, this is 2z square. This is 2z square plus 4z plus 4. Right? So we can take common here. In the denominator, what is common? 2 is common. I is equal to integration of 2 dz divided by 2 is taken common, within bracket z square plus 2z plus 2. Here this 2 gets cancels. So what do we get now? So I is equal to integration of dz divided by z square plus 2z plus 2. So now you should convert into standard form. You know how to convert into standard form, isn't it? Both the terms are there, that is z square as well as z. So let us convert this z square plus 2z in terms of perfect square, that is a square plus 2ab plus b whole square. So here the coefficient of z square is already positive 1. So let us convert this expression in terms of a plus b whole square form. So therefore I is equal to integration of dz divided by a whole square. What is a whole square here? It is z whole square plus 2 into z into 2ab. That is 2 into z. Here is z. What should be the value for b, so that we can have 2z? This 2z should be multiplied by 1 plus, what is b whole square? 1 whole square. So we are getting the first two terms. Z whole square is z square. 2 into z into 1 is 2z. But there is plus 1. But here it is plus 2. Let us write plus 2 first. But is there 1 out here? No. Cancel it. So it is minus 1. So or I is equal to integration of, this is dz divided by, you know this formula, z plus 1 whole square plus 2 minus 1 is 1. You can write it in terms of 1 whole square. 2 minus 1 is 1. So 1 can be written in terms of whole square, that is 1 whole square. So what is the formula now? So instead of x there is z plus 1, instead of a there is 1. This is the first standard integral in method of substitution. So what is the formula? 1 upon a, 1 upon 1, tan inverse, what is x here? Z plus 1 upon 1, bracket closed, plus c. So 1 upon 1, you don't have to write it. So it is tan inverse within bracket. What is the value for z? What is z here? It is tan x by 2. Z here is tan x by 2, then plus 1. You don't have to write whole divided by 1 because there is 1. So if there is 1 in the denominator, you don't have to write it. Okay? Then you should write plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we will do next type of integration. So you should know the method how to integrate the next type of integration. Okay, so let us evaluate integration of the form. Let us evaluate integration of the form. We'll just discuss about the method only. We'll just discuss about the method only, then we can do problems from the book. Okay, so now you have if you have integration of the form dx divided by a sine square x plus b cos square x. If you have such type of integration, how will you do it? Both sin square x and cos square x are there, and a is the coefficient of sin square x and b is the coefficient of cos square x, and it is a sin square x plus b cos square x. So how can you evaluate this integration? Here a and b are constant. So in this case, you should convert it into tan x and sec x form. Okay, and you know that the differentiation of tan x is sec square x. So first of all, in order to convert this sin square x into tan square x, you should divide it by cos square x. So if you divide denominator by cos square x, you should also divide the numerator by cos square x. That is, dividing both the numerator and the denominator by what? Cos square x. Okay, so this is I is equal to integration of, so you divide both the numerator and the denominator by cos square x, so it is 1 by cos square x dx, and in the denominator also you should divide both the term by cos square x, right? Then plus, so this is your cos square x plus b cos square x divided by cos square x. Okay, so here cos square x will be cancelled, so you will get integration of sec square x dx divided by, it is a tan square x, and this is plus b. This will be cancelled. Now you can easily integrate that. So now we can put, let z is equal to tan x. Now you can evaluate this integration. So this is only the method. Okay, so whenever you have such type of integration, that is integral of dx divided by a sin square x plus b cos square x, you divide both the numerator and the denominator by cos square x, convert them into tan x and sec square x form, so we can assume tan x as z. So you can easily evaluate this integration. Okay, so let us do related problems of this type of integration. So you can copy it. So now we'll do this question number 22. So let us evaluate this integration. That is integration of dx divided by 1 plus cos square x. So how can you evaluate this integration? So in this case, we can use the method as we have done in the previous problem. Is that clear? That is, we have done integration of the form integration of dx divided by a sin square x plus b cos square x. But in this case, we have 1 plus cos square x. But instead of this 1, you can write sin square x plus cos square x, isn't it? So let us write here, therefore, I is equal to integration of dx divided by, what is 1? Instead of 1, you can write sin square x plus cos square x plus, instead of 1, sin square x plus cos square x is 1. Then write down plus cos square x. Right? So, or I is equal to integration of dx divided by, this is sin square x plus 2 cos square x. So I hope you have understood it. So now in this case, this is the integration of the form integral sin dx divided by a sin square x plus b cos square x, as we have done the method in the previous problem, right? So instead of a there is 1, instead of b there is 2, there is sin square x and cos square x. So what is the method for integrating it? You know the method. You have to convert it into tan x and sec square x form. You have to divide both the numerator and the denominator by cos square x. But you don't have to write here dividing both the numerator and the denominator by cos square x and all those sort of things. Okay, you don't have to write it, just divide it by cos square x, right? So, or I is equal to integration of, this is 1 by cos square x dx divided by sin square x divided by cos square x plus 2 cos square x divided by cos square x. Understood now? That means we are dividing both the numerator and the denominator by what? Cos square x. Okay? So let us simplify it. I is equal to integration of what is 1 by cos square x? It is sec square x dx divided by what is sin square x by cos square x? This is your tan square x plus this is only 2 here, cos square x gets cancels, right? Now you know that the differentiation of tan x is sec square x, so we can use the method of substitution in this case. So let z is equal to tan x. So now write down differentiating both the sides with respect to x. So this is dz by dx is equal to what is here? It is sec square x. Now you do cross multiplication, dz is equal to this is your sec square x dx. That means we are getting the numerator, right? So therefore what is I? Let us put these values in I. I is equal to integration of what is sec square x dx? It is dz divided by what is tan square x? Z square plus this 2 can be written in terms of whole square, that is root over 2 whole square. I think you have understood it. So this is standard form number 1 in method of substitution. Instead of x there is z, instead of a there is root 2. What is the formula? First standard form in method of substitution, 1 by a, 1 by root 2 tan inverse within bracket x by a, that is z upon root 2 bracket closed plus c. Okay, now let us put the value for z. What is z here? Tan x. So or I is equal to 1 upon root 2 tan inverse within bracket 1 upon root 2. What is the value for z? It is tan x. It is tan x bracket closed plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do next question, that is question number 25. So you can do these number 23 and number 24 at home. That is number 23 is integral sine dx divided by b square cos square x plus a square sin square x. You divide both the numerator and the denominator by cos square x, convert into tan x and sec square x, then assume tan x as z. Here also same method can be used for question number 24. So 23 and 24 are your homework. You can do it at home. Okay. So let's do this question number 25. So here the question is I is equal to integration of dx divided by 3 sin x plus 4 cos x whole square. But this expression is not in the form of dx divided by a sin square x plus b cos square x. But if you expand it, 3 sin x plus 4 cos x whole square, using a plus b whole square, you can have 9 sin square x plus 4 3s are 12, 2s are 24, sin x cos x plus 16 cos square x. You have sin square x and cos square x are also there. Okay. So in this case also you should divide both the numerator and the denominator by cos square x, because if you expand it you will get sin square x, cos square x and sin x cos x form. So in this case also you should divide both the numerator and the denominator by cos square x. Let us convert them into tan x and sec square x form, and you can assume tan x as z, right? So let us divide both the numerator and the denominator by cos square x. So it is 1 by cos square x dx divided by, this is 3 sin x plus 4 cos x whole square divided by, this is cos square x. Understood? So let us simplify now. Or I is equal to integration of, what is 1 by cos square x? It is sec square x dx divided by, in the denominator both the fractions are square, isn't it? You can write it within whole square. So in the bracket you can have the fraction 3 sin x plus 4 cos x, that is 3 sin x plus 4 cos x divided by, this is cos x whole square. Is that clear? So in both the numerator and denominator there is a square. You can write it within whole square, that is 3 sin x plus 4 cos x divided by cos x whole square. So let us separate the term here. Or I is equal to integration of, this is your sec square x dx divided by, this is 3 sin x divided by cos x plus 4 cos x divided by cos x whole square. Here cos x will be cancelled. Or I is equal to, this is integration of, this is your sec square x dx divided by, this is 3 tan x plus 4 whole square. So now you can easily evaluate this integration, because you know that the differentiation of tan x is sec square x. Either you can assume tan x as z, or you may assume 3 tan x plus 4 as z, because the differentiation of 3 tan x plus 4 is also sec square x, isn't it? So let us assume, let z is equal to 3 tan x plus 4. Let z is equal to 3 tan x plus 4. So differentiating both the sides with respect to x. So what do we get? This is dz by dx is equal to 3. What is the differentiation of tan x? It is sec square x, right? So let us find out the value for the numerator, that is sec square x dx. So let us do cross multiplication now. Or, so what do we get after cross multiplication? dz is equal to 3 sec square x dx. Is that clear? Now let us take this 3 to the right hand side or left hand side. 3 is taken to the left hand side, so it becomes dz by 3 is equal to, this is your sec square x dx. Okay, so let us put it in I. Therefore I is equal to integration of, what is sec square x dx? dz upon 3 divided by, in the denominator, what is 3 tan x plus 4? What is 3 tan x plus 4? It is z square. This is your z square. Or I is equal to 1 upon 3 integration of, now this is your z to the power minus 2 dz. That is, z square is taken to the denominator, z square is taken to the numerator, and it is written as z to the power minus 2. So z square is taken to the numerator and it becomes z to the power minus 2. So here you can use the formula of x to the power n. That is, what is integration of x to the power n? It is x to the power n plus 1 divided by n plus 1. Or I is equal to, this is 1/3 into, what is the integration of z to the power minus 2? It is z to the power minus 1 divided by minus 1 plus c. Or I is equal to, this minus sign is taken outside, minus 1 upon 3, z to the power minus 1 is taken to the denominator to make it z to the power plus 1. Then you should write plus c. So now put the value of z. Or I is equal to minus 1 upon 3 into, what is the value for z? Here the value for z is 3 tan x plus 4. It is 3 tan x plus 4. Then you should write plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do question number 26. That is integration of sin x dx divided by sin 3x. So in this case also we should use the formula of sin 3x. So you should know the formula of sin 3x. What is the formula of sin 3x? 3 sin x minus 4 sin cube x. Okay. So we can use the formula for sin 3x as 3 sin x minus 4 sin cube x. And this is the formula from the chapter multiple angles in trigonometry. So let us write here first I is equal to integration of sin x dx divided by what is sin 3x? It is 3 sin x minus 4 sin cube x, right? So or I is equal to integration of this is sin x dx divided by what is common out here? Sin x is taken common and within bracket we have 3 minus 4 sin square x. Is that clear? So here sin x will be cancelled. Or I is equal to integration of this is dx divided by 3 minus 4 sin square x. So I think you have understood it. So now what is the method for integrating it? Again you have to simplify it. 3 minus 4 sin square x. You should convert it into the form of integration of dx divided by a sin square x plus b cos square x. But there is 3 here. This is only 3 and this is minus 4 sin square x. So actually this is 3 into 1, isn't it? 3 into 1, and instead of 1 you should put sin square x plus cos square x. Or I is equal to integration of dx divided by, actually this is 3 into 1. 3 ones are 3, isn't it? Minus 4 sin square x. So next, instead of 1 what should we put? I is equal to integration of this is dx divided by 3 within bracket. This is your sin square x plus cos square x minus this is your 4 sin square x. So I think you have understood it. Okay. So let us simplify it. Or I is equal to integration of this is dx divided by, in the denominator multiply by 3 here, it is 3 sin square x plus 3 cos square x, 3 cos square x, then minus 4 sin square x, minus 4 sin square x, right? So let us simplify it. I is equal to integration of dx divided by, now in this case you can simplify the similar terms, that is 3 sin square x minus 4 sin square x can be simplified. So you should write here 3 cos square x and 3 sin square x minus 4 sin square x is minus sin square x, right? 3 sin square x minus 4 sin square x is minus sin square x. Now this is in the form dx divided by a sin square x plus b cos square x. Here a is minus 1 and b is 3. So we can use the method, that is you have to convert this expression in the form of tan x and sec square x form. So you should divide both the numerator and the denominator by cos square x. Or I is equal to integration of this is 1 by cos square x dx. In the denominator also you should divide it by cos square x. This is 3 cos square x divided by cos square x minus sin square x divided by this is cos square x. Okay. So we are converting it into tan x and sec square x form. Or I is equal to integration of what is 1 by cos square x. It is sec square x dx divided by, this will be cancelled, 3 minus this is your tan square x. Is that clear? Now you can do the method of substitution, because you know that the differentiation of tan x is sec square x. So let us assume, let z is equal to tan x. So we can write here differentiating both the sides with respect to x. So differentiating both the sides with respect to x. Therefore, it is dz by dx is equal to, this is your sec square x. Now cross multiply, or what is dz is equal to, this is sec square x dx. Is that clear now? So what is I is equal to now? I is equal to integration of what is sec square x dx? It is dz divided by, in the denominator, how will you write 3? You can write 3 as root over 3 whole square minus, what is tan square x? Here tan square x is z square. Now you know that this is the standard form from method of substitution. That is the third standard form. Instead of a there is root 3, instead of x there is z. The formula is integration of dx divided by a square minus x square, which is equal to 1 upon 2a log within mod a plus x upon a minus x, mod sign close, the base is e. Then what should you write? Plus c. This is the formula. Instead of a there is root 3, instead of x there is z. So what is the formula that you can use here? I is equal to 1 by twice a, 1 by 2 into a means root 3, then log within mod. What is a plus x? Root 3 plus z. What is a minus x? Root 3 minus z, mod sign closed, plus c. And here the base is e. Right? So now we can put the value for z. What is the value for z actually? The value for z is tan x. Or I is equal to, this is 1 by 2 root 3 log within mod. It is root 3 plus, what is the value for z? It is tan x. It is tan x divided by root over 3 minus tan x, mod sign closed, plus c. This is the answer, and here the base is e. So this is the final answer. So I think you have understood this question. Similarly you can do this number 27. So how will you do it? Question number 27. Integral sine cos x dx divided by cos 3x is there. In this case we can use the formula of cos 3x as 4 cos cube x minus 3 cos x. And similar method may be used for this question number 27 as we have done in previous problem, that is in question number 26. So this is your homework, that is question number 27. So you can copy it. So this much is for today. So today also we did some problem. You revise all the problems that we did today, and in the next online class we will do more problems on this integration of some special form of functions. So this much is for today.